Limits and continuity. Let's start off with limits. Limits can be a little bit tricky in the third dimension. Suppose you come to know the following. The limit as x comma y goes to AB. That means x goes to A, y goes to B. The limit of this, of the f function, is 5. And the limit as xy also goes to the point AB of g of xy. This is equal to 3. That's given. They ask you questions based on that information. What would be the limit of 4 times f of x divided by g of x? Now limits are very, very friendly. Very friendly. You can take the limit as xy goes to AB. I'm going to stop writing that. You can take the limit as xy goes to AB of 4, and then times that by the limit as xy goes to AB of f of x, and you can divide that by the limit as xy goes to AB of g of x. But as x and y change, 4 is a constant. It stays 4. This limit, they outright told me on top it equals 5. Oops. One major mistake. It should be 2 variables. Sorry. It should be f of x comma y, g of x comma y. We were told that this limit was 5. And we were told that this bottom limit is 3. So there is the answer. 20/3. Done. Given the same information on the first 2 lines, we'll take the limit of something different. The limit of f of xy minus g of x comma y divided by f of x comma y. We want the limit of that. Well, it's the limit of this, which is 5, minus the limit of that, which is 3, divided by the limit of that, which is 5. The answer is 2/5, 0.4. Limits are very friendly. If you have the limit of a fraction, take the limit of the top divided by the limit of the bottom. If the top also happens to be a subtraction, you subtract the limit and then divide by the limit of the bottom. Limits are very, very friendly. You can do anything to limits. Anything reasonable. I mean, if it says to add, it says find the limit of this plus that, and you multiply the answers, that's not reasonable. You add the answers. What is the limit as x comma y goes to 2, 1 of x plus 3y squared? You can try directly substituting. X is 2 plus y is 1. 1 squared is 1. 3 times 1 squared, which is 2 plus 3, plus 1 squared is 1, 3 times 1 is 3, and you get 5. You wanted to take the limit as xy approaches the origin. 0, 0 just happens to have a name called the origin. of 5x plus 3xy minus 1, well, you get 5 times 0, which is 0, plus 3 times 0 times 0, which is 0, because x goes to 0 and y goes to 0, and minus 1. The answer is negative 1. It's negative 1. There were some limit problems. We'll do some more, and I want to point out that possibly what I showed you may not work. What I've done so far may not work. So suppose you had to do the following. You have the limit as xy approaches 0, 0, and you get xy over x squared plus y squared. Now if you directly substitute, you're getting 0 over 0. 0 times 0 is 0. Remember, x and y are both 0. 0 squared plus 0 squared is 0. So this is indeterminate. Indeterminate. Now, what if we go to xy in different ways? What if, so there's different paths to go to 0, 0. You could, for example, always let x be 0. That would be one path. Here's x and here's y, and we want to go to the good old origin. If you let x be 0, that means you're along this line. That is, y would be approaching 0. That's one path. Another path is you can go along the line y equal x. Here's the line y equal x. You can start here, for example, and you could approach the origin. Of course, you would have to say one or the other letter is approaching 0. So as x approaches 0, you're along the line y equal x. Say you're right here. And as x approaches 0, you're getting to the origin. You're approaching the origin along that line. Well, let us do this. Let us path 1, path 2. So with respect to path 1, we're taking the limit as y goes to 0, but x is 0. So if x is 0, we have 0 times y divided by 0 squared plus y squared. That is, we have the limit as y approaches 0. Now that's 0. 0 squared plus y squared is y squared. Now, here's the game here. Y is never 0. Y is approaching 0. It's never 0. So, I know the top is 0, and the bottom is not 0. The only way to square something and get 0 is if you're squaring 0, but we're not. So, via path 1, the answer was 0. Let's go along path 2. Let's go along path 2. Path 2 says that y becomes x. Y equals x. And let x go to 0. So y equals x. Okay, so we have the limit as x goes to 0. So wherever I see y, I put x. In the top, I have x times y, which is really x times x. And in the bottom, I have x squared plus x squared. I have 2x squared. But as long as x is not 0, and it isn't, this reduces to 1. That is, I have the limit, as x gets closer and closer to 0, of the number a half. But that equals a half. This limit does not exist because I took different paths and I got different answers. So you have to go back to the ones I've done a few minutes ago and see if possibly if you went two different routes, will you get different answers? You need to be very careful with these Calc 3 limits. The last one was good because when you directly substituted, you got indeterminate, so you had to look further. I think it's worth doing some more. Suppose you have this. And when you have x times y and x squared plus y squared, you might start thinking that taking a different path might help. But this one has neither of the stuff I said. Now, if you're directly substituting, once again you'll get 0 over 0. Now you go different paths. You can let y be 0 and let x approach 0. Or you can let y be replaced with x and then let x go to 0. In either way, x comma y is approaching 0, 0. So let's do this one. Now y is 0. That's 0. That's 0. So what you have is 2x over 2x squared. Now since there's no y's, I won't even mention y. But I will mention that reduces, as long as x is not 0, and it is not, it reduces to 1 over x. And 1 divided by a number close to 0 is infinity. In fact, it's plus or minus infinity. Because if x is going to 0 from above, if x is approaching 0 or from above 0, 1, a half, a quarter, a fifth, the sevens, the millions, the 10 millions, always positive. Well then 1 is always positive and x is always positive, so you're going to get positive infinity. But if you're going to 0 through negative numbers, negative 1, negative a half, negative a third, negative a million, 1 is always positive, but x is always negative. So you're going to approach negative infinity. So this limit doesn't exist. And I can't even tell you if it's positive infinity or negative infinity. Let's look at the right one. We want to take the limit as when y equals x and x approaches 0. So y becomes x. So we get 2x minus x squared over 2x squared plus x. Well, if I directly substitute x as 0, I get indeterminate. I mean, you can use L'Hopital's rule, I guess, at this point. But I'll factor. I choose to factor. Since there's no y's, I won't even bother saying y is x. You can factor out an x from the top, and you get 2 minus x, and then x from the bottom, and you get 2x plus 1. And since x is never 0, I can cross this out. And now when I directly substitute, I get 2 over 1, which is 2. Well, again, I'm getting different answers. The limit doesn't exist. But I knew that from the first part, because coincidentally, it didn't exist in the first part. I bet if you took a different path, you can get 2 different answers but finite. Like 2 and maybe on the other path you can get 4. Once that happens, it does not exist. You have to be careful with limits. Depends upon the path that you take. Now, suppose you have something like this. The limit as xy approaches 0, 0, and you have the sign of x squared plus y squared, and you're dividing by x squared plus y squared. Now, there are 2 ways to handle this, but you really should know this rule. The limit as say x goes to 0 by sine x over x is 1. Now let's look at this very carefully. What you're taking the sign of and what you're dividing by, they have to be the same. And as x goes to 0, these have to go to 0. As x goes to the value it's going to, these 2 have to go to 0. They have to be the same and go to 0. So for example, you have the limit as x goes to 5 of sine of x minus 5 divided by x minus 5. These have to be the same, and they are. And as x goes to that number, these have to go to 0, and they do. That equals 1. If you have the limit as x goes to infinity of sine 1 over x divided by 1 over x, both of these are the same, and as x goes to that number, both of these are going to 0. 1 divided by a really, really large number is 0. This is 1. Okay. Is this limit equal to 1? Does this limit equal to 1? The answer is yes, it does. For 2 reasons. What I'm taking the sign of and what I'm dividing by, they're the same. That's first thing. And as xy goes to 0, 0. As x goes to 0 and y go to 0, these go to 0. That's enough for me. It does equal 1. It does equal 1. I think that's the way to do that problem. I think that's a good one. But x squared plus y squared, that makes me think polar coordinates. I know that r squared, r is in polar, r squared translates to x squared plus y squared. That is, we have the limit of sine of r squared divided by r squared. Now, if xy goes to 0, 0, if xy goes to 0, 0, then r goes to 0. Because if x and y are going to 0, then x squared plus y squared is going to 0. That is, r squared is going to 0. But that implies that r is going to 0. If r squared is getting closer and closer to 0, that means r is getting close to 0. So r is approaching 0. What I'm taking sine of and what I'm dividing by are the same. And as r goes to 0, the r squares are going to 0. Ooh, that's 1. So it's just another tool that you can have to solve some of these integrals, excuse me, some of these limits. Of course, you're going to need to know the three rules, or some of the rules. Y is equal to R sine theta, and that x squared plus y squared is identically r squared. So somebody gave you the limit as xy approaches 0, 0 of xy squared over x squared plus y squared. Now if you directly substitute, you're getting into trouble because you're going to get 0 over 0. So let us do a transformation to polar. Let r go to 0. Well, whenever you have x, that means r cosine theta. And y squared will be r squared sine squared theta. And this gets divided by x squared plus y squared, which is r squared. So the r squares cancel out, and what you have is the limit as r approaches 0 of r times cosine theta times sine theta. Cosine theta times sine squared theta. That's the constant. This has nothing to do with r. But r goes to 0. So you get 0. I mean, you can take the limit of the first, which is 0, times the limit of the second, which is this constant. And 0 times that is 0. So it turns out that this limit is 0. But the nice part is we didn't have to take different paths. We didn't have to try this path and that path. Turns out whatever path we're going to try is going to give us 0. One way of going to 0, 0 is to let y be 0 and let x approach 0. That is, you're approaching 0, 0 along the x-axis. So y is 0. So the top is going to be 0. And the bottom will just be x squared. So we don't even have any y's in it, so let's not mention it. Since the bottom is not 0. The bottom is 0 when x is 0. But x is getting closer and closer to 0. It won't be 0. So we're getting 0 over not 0, which is 0. Which drives are what we got before. But doing it the way I just did it, this path method, maybe if I would try a different path, I'd get a different answer. It turns out we won't, because when we converted to polar, everything worked out nicely. So there's a way to get around having to do some path problems. For example, if we go back to an earlier one, suppose you have the limit as xy approaches 0, 0 of y divided by x squared plus y squared. Suppose you have this. Well, if you let y equal 0 and x approach 0, then you get 0 over x squared plus 0 squared, which is x squared. And since x is never 0, you get 0 over not 0, which is 0. Okay? But now, if I let, I don't know, y equal 2x, and then I let x go to 0, then y would also be going to 0. So y becomes 2x. So the top is 2x, and the bottom is x squared plus y squared, 4x squared. That is you get 2x over 5x squared, the limit of that. So you have the limit as x goes to 0. Now since x is not 0, this is 2 over 5x. So 2 over 5x, which is plus minus infinity. Doesn't exist. Let us see what happens if we go to polar. We have the limit as r goes to 0. The bottom, that's just r squared. And the top is sine, y is the sine, right? It's r sine theta. Since r is not 0, I can divide. I can divide top and bottom by r. The limit as r goes to 0, a sine theta over r, not 0, excuse me, divided by r. That's undefined. This is undefined, which is exactly what we got using one of the path methods. Okay, it was a one-shot deal. What we get using polar is what we get. There's only one way for r to go to 0. R goes to 0. But for x, y to go to 0, 0, there's many ways. You can go along the parabola y equals x squared and let x go to 0. X is going to 0. Of course, you can go in this direction. X is going to 0. And y is also going to 0. You can go along that curve. You can go along that curve. As long as you end up at 0, 0, you can take that path. Hint, I'm suggesting that there's an infinite number of paths that you can take. And possibly all but one of them will give you the answer of 1/2. And that one isolated case will give you the answer 2/3. Limit can't have two answers, so the limit will not exist. Converting to polar coordinates gets you out of that problem, which is good. You don't want to have problems. Okay. Suppose you have the function f of x, y, z is equal to 1 over the square root of x squared plus y squared plus z squared. The question is, where, if anywhere, is this function continuous? Now, x squared plus y squared plus z squared, that's continuous everywhere. Okay, it's a sphere. Okay, it's a sphere. X squared plus y squared plus z squared is continuous. And the square root of it, the square root of a continuous function is continuous. And the numerator is 1. That's continuous. That's continuous. It goes like that. It's 1. It's always 1. If the top is continuous and the bottom, the top is continuous on its domain and the bottom is continuous on its domain, that means the division is continuous on its domain. Domain for the top is x, y, and z can be any number because 1 is always 1. In the bottom, you have a problem. What's underneath the square root sign cannot be 0. It can't be negative either. But you know what? Good luck in squaring x, y, and z and adding them up and getting a negative number. Okay. It can't be less than or equal to 0. But that implies it can't equal 0. Because it'll never be less than 0. When does it equal 0? That implies x, y, z cannot be the point 0, 0, 0. It's not defined there. F of 0, 0, 0 is undefined because you're getting 1 over 0. It's undefined. It can be continuous where it's undefined. In this case, that is the answer. It's continuous in all of R3 minus the origin. Or you can say, is this continuous at 0, 0, 0? It's continuous everywhere except 0, 0, 0. Suppose you have f of x, y, z, and this is equal to the sine of z divided by e to the x plus e to the y. Now, sine of z is a continuous function. Only big deal is the angle is called z. The height, call it y. Doesn't matter what you call it. Call it j. Okay. Sine of z is continuous. E to the x is continuous. E to the y is continuous. It's all continuous, and it's continuous on negative infinity, infinity. Z can be any value. It's continuous. If this is y equal e to the x, that means this is the x-axis. X can be anything from way left, negative infinity, all the way up to x being positive infinity. If you have e to the y, let the horizontal axis be y. Well then, it's continuous from negative, where y goes from negative infinity to positive infinity. The answer is it's continuous for all x, y, z's, for all points. It's continuous for any triple, 7, 2, 1, for any three numbers separated by commas. Product of continuous functions is continuous. X, that's continuous. I mean, just picture the x-axis. It's continuous. Goes from negative infinity to positive infinity. It won't jump. It'll go 1, 2, 3, or this point, the point next to it, the point next to it. It doesn't jump. It doesn't jump. Same thing for y. Same thing for sine of z. You don't have to lift your pen to graph it. To graph y equal x. Something equal x. Suppose y equals x. Well, that goes this way. If something equals y, if w is equal to y, it goes that way. It's continuous. And a product of continuous functions is continuous. This is continuous, period. Continuous everywhere. You can say that. It's continuous everywhere. You don't have to say it for all x, y, z. It's continuous everywhere. If you had z is equal to, say, z over x squared plus y squared minus 4. Well, z is always continuous, and if you have w is equal to z, here's the w, y equals x. Here's the z-axis, here's the w equals z. It's continuous. What if I said w is equal to x squared plus y squared minus 4? Well, this is like a circle. W plus 4 is x squared plus y squared. You give me different w's, I'll give you a circle whose r squared will be 4 more than w. So this is just a circle. It's a circle, which is continuous. The top is continuous, the bottom is continuous. On the domain, this fraction is continuous. Sometimes you'll find values other than you'll find values in the domain that make it discontinuous. But this function, the top is continuous and the bottom is continuous. But the bottom can't equal 0. That's the domain. The bottom cannot equal 0. That is, this can't be 4. X squared plus y squared can't be 4. That's a circle of radius 2. So it is discontinuous at points that satisfy x squared plus y squared equals 4. We can't allow that. It will be discontinuous there. The function's not defined. You have to look at their domain. D for domain. The function is not even defined for x squared plus y squared equals 4. This is going to be discontinuous for all those points. X squared plus y squared equals 4. So if x is 2 and y is 0, then x squared plus y squared will equal 4. And z can be anything. It will be discontinuous at that point. If x is the square root of 2, you square it, you get 2. If y is negative the square root of 2, you square it, you get 2. That's going to give you 4. Z can be anything. The problem is x squared plus y squared equals 4. That will not be continuous there. It won't even be defined. F of that. It won't be defined. F of that x, that y, and that z. Z will be the anything. That's what goes in the numerator. It says z goes in the numerator. The denominator will be 0. Because x squared plus y squared is 4. That's 4. When you take away 4, you get 0. It's not defined there, which means it's discontinuous there. You definitely have to find where the function is not defined. It certainly won't be continuous there. But then you have other situations that can come up. Okay, how about this one? Suppose they tell you that f of t is t squared and g of xy is 3x minus 2y. And they want to know about this where they want us to talk about the continuity of f circle g. F circle g of xy. Why fy? Because first you do f of g of that. And you don't take g of t's. Let's look right here. You take g of xy's. That is, you take f of g of xy. namely 3x minus 2y. Now what's the job of f? It squares what goes in there. So you get 3x minus 2y squared. Now when you look here, there's no problem. You can triple any value, you can double any value, you can then subtract those two values, and then you can square it. You'll never run into trouble. Okay, but now we have to be very careful. We're taking g of stuff. Can we take g of anything? Yes. X and y can be anything. We're never dividing by 0, and we're never taking the square root of negative numbers. You can triple any number, and you can double any number, and then you could subtract them. So what goes in, so g of xy can be xy, I meant to say. xy can be anything. Because we can take g of anything. So xy can be anything. Now we're taking f of this. We're taking f of this. Can we take f of anything? The answer is yes. You can square anything you want. You can square anything you want. So it's continuous everywhere. There's no problems here at all. But now, what if I define f of t to be 1 over t? And I define g of xy to say be 1 over 3x minus 2y. Now you really shouldn't look at the end result to base your answer. Because if you compute f circle g of xy, which means f of g of xy, and g of xy just happens to be what it happens to be. Now, what does f do to what's in the brackets? And t is the same as t over 1. What did f do to t over 1? It took the reciprocal. What's f of this? Take the reciprocal. You get 3x minus 2y, which is defined everywhere. You can triple any number, you can double any number, then you can subtract the two. You really shouldn't be looking just there. You need to be looking everywhere. First, you're finding g of stuff. What can you not take g of? What can you not take g of? And I want to change the problem just a little bit. I want to put y on the top. I want g to have y on the top. So f, which takes the reciprocal, would give me this. Oops. So I get over y. You really shouldn't just look at that one. You are taking g of stuff. What can you not take g of? Well, the bottom better not be equal to 0. That is 3x better not be 2y. X cannot be 2y over 3. As long as x is not 2y over 3, you can take g of anything. That is, when you pick y and you double it and divide it by 3, that better not be the x value. Y can be anything, but x better not be twice y over 3. Otherwise, you'll be dividing by 0. You'll be dividing by 0. And you can't do that. That's one problem. Now, the second problem that might come up is you are taking f of stuff. You are taking f of that mess. What can you not take f of? You can't take f of 0, because 1 over 0 is not defined. What you are taking f of, cannot equal 0. if a fraction is 0 and the top is 0. Y cannot equal 0. That's another part of the domain. That's another restriction on the domain. Okay. Now we look at the final answer. We look over here. And you say, well, the numerator's always fine. The denominator can't be 0. But I already have that. So definitely when y equals 0, or when x is 2y divided by 3, it's not even defined. But there could be other places for it to be discontinuous. There can be other places where it can be discontinuous. And we talked about it. The final answer is discontinuous where y is equal to 0. So the final answer, it is discontinuous when y is equal to 0, where y equals 0, and where x is 2/3 y. That's where it's discontinuous. It's continuous everywhere else. Okay, on that note, we are finished with this section. Next section is entitled Partial Derivatives.